Ladies and gentlemen, welcome to this webinar. The topic that we will go through today is the description of an ingredient for deodorant application. The ingredient is called DEOHAP Dry, and this is a raw material, is a patented raw material of which we will see all the details. It's a material in mineral form that is specific for the sweat and odor control through a very innovative and unique mechanism of action. Before starting the introduction of the raw material in object, I will just mention the main areas of technology where Kalichem's activity is involved. Basically, Kalichem is an Italian company operating in a personal care field since approximately 20 years. Our activity in terms of development and production of raw materials started with the development of lipoprotein and lipoamino acids derived from olive oil. Basically, Kalichem has a family of patented emulsifiers and surfactants based on the olive oil technology. Throughout the years, the developing activity of Kalichem expanded. As a matter of fact, we have implemented in our production the development of ingredients coming from molecular biology and biotechnologies. Namely, we have, for instance, active ingredients based on DNA, the use of deoxyribonucleic acid in pure form from biological sources, and products coming from biofermentation. And last but not least, and that will be the topic of today, we have a family of ingredients based on the use of functionalized hydroxyapatites based basically on biomimetic materials. So the hydroxyapatite that we will see today for the deodorant application is basically a biomimetic material, but we will see the details of this category of ingredients right now. So, as mentioned, the product we are describing today is called the DEOHAP Dry. DEOHAP Dry is an absolute innovation in personal care field because this is a product that is patented for deodorant application. And in such a case, the patent relies on the use of hydroxyapatite functionalized with oligoelements, so with ions, such as, for instance, zinc and magnesium. This ingredient is internationally patented, and it is a product that has a functional target which is quite challenging, because basically what we are offering in the market is an ingredient that should replace antiperspirant actives. We will see during the presentation the differences between this product and the most popular antiperspirants found on the market, namely aluminum-based substances. And what we will see is that DEOHAP Dry, despite having a totally different nature and mechanism of action, is able to stand performances some way comparable to the performances of antiperspirants. At the end of the day, what we will see will be an activity of this specialty that will guarantee a long-lasting sweat and odor control that was evaluated until 48 hours after the first application, and an ingredient with a microbiota-friendly nature. Of course, the market in this moment is trying to move away from aluminum salts derivatives. And the good news is that definitely this raw material does not contain aluminum salts in its composition. So before analyzing the, let's say, the characteristics of DEOHAP Dry, we will make a refresh of the main concepts linked to the physiology of the sweat and how the active ingredients found on the market work. Basically, what we know regarding sweat. Sweat basically is an odorless liquid which is produced by sweat glands. We know that the sweat at a certain point does not have the best odor in the world, and the reason for that is because the sweat that is produced by the sweat glands in the human body at a certain point is metabolized by skin bacteria. So the odor of the sweat is not, let's say, an intrinsic characteristic, but it comes out after the metabolism, after that the bacteria metabolize the sweat components. So basically, this is the physiology of sweat and the formation of odors. In detail, here we can see some images that explain probably more clearly the formation, the genesis of the unpleasant odors. So we can see on the left side of the screen that in the axillary area, there is a population of bacteria, which represents, for instance, the local microbiota of the armpit. And we know that throughout the day, through the sweat glands, a certain amount of sweat, indeed water, is produced. So basically, the interaction that will take place between the skin bacteria and the sweat components will lead to the formation of the sweat odors, the typical malodorous the typical malodorous gases that the deodorants and antiperspirants are aimed to fight against. So, what is the traditional approach of personal care and the antiperspirant market? Basically, the traditional approach regards the use of ingredients like, for example, aluminum chloride and aluminum chloridrates. These specific substances, in fact, are able to basically form a sort of plug that settles on the sweat glands, avoiding the physiological perspiration. This strategy is for sure highly efficient and shows high efficacy. The problem is that in order to accomplish this goal, what we are sacrificing is the regular perspiration of the skin. So as a result of these let's say, aggressive activity of aluminum salts, what will happen is that we will have frequently skin irritation, impair of skin microbiota, and this will take place not only because of the presence of chloride on the skin, but also because of the physiological change of the pH that will take place inside the armpit, because basically these ingredients with the aluminum derivatives have a very acidic pH. So the extremely acidic pH on the of this deodorant, of this let's say finished product, are able to affect the local microbiota, promoting some consistent damages. So in general, what we can say is that aluminum salts are substances that are able to inhibit the regular perspiration of the skin through a plugging action that basically obstructs the sweat duct. Of course, if this mechanism is prolonged, so I mean, if our skin is exposed for a lot of time to the activity of these substances, we are facing a concrete risk of an irreversible obstruction of the sweat glands. So, I mean, the market is very well aware of this risk, and in fact, one of the most popular trends today in personal care industry is trying to find some alternatives to the use of these antiperspirant substances. So, here we are to the DEOHAP Dry. So this is the patented molecule that is included inside the raw material. So as anticipated at the very beginning, this DEOHAP Dry specialty contains biomimetic hydroxyapatite. The biomimetic hydroxyapatite is a mineral with a biomimetic nature. When I say biomimetic, I mean that this mineral is physiologically occurring in the human body. For example, we can find it in the tooth, in the bones. So what Kalichem did is setting a method, a production method with which we are able to obtain from a synthetic process this biomimetic substance, which has exactly the same behavior from a physical and chemical point of view as the physiological hydroxyapatite. So this mineral has very interesting characteristics. It is, as a matter of fact, one of the most important products where Kalichem focuses its developing activity. We have hydroxyapatite versions, for example, in sun care, in oral care, and indeed in deodorants. So in the case of deodorants, the most relevant characteristic of the biomimetic hydroxyapatite is its functionalization with divalent cations, namely magnesium and zinc, whose addition in the hydroxyapatite network enables to obtain very interesting characteristics, which we will see immediately. So here we have an overview of the main mechanisms of action and the main functional characteristics of the biomimetic hydroxyapatite. We see 4 main points. We will go through each of them to explain how this raw material is able to carry out 2 main activities. The first one is the adsorption of the sweat fluids, which comes from a high compatibility of the hydroxyapatite mineral with the fluids of sweat. And last but not least, we will see the interaction that the hydroxyapatite is able to establish with malodorous gases through its electrophilic character. In any case, we will see everything in detail. So here we have a picture of hydroxyapatite, because nothing speaks better than pictures. Basically, here we can see how the biomimetic hydroxyapatite mineral looks when we watch it at the SEM microscope. So basically what we can see is that the surface of this mineral shows an extremely porous and large superficial area. So this highly porous substance is the main reason for which the hydroxyapatite is highly complementary with the sweat fluids. And in detail, this porous structure will make sure that some specific hydrophilic groups found in the hydroxyapatite molecules will be able to interact with the water found on the sweat. The hydroxyapatite, in fact, is a mineral that contains mainly calcium, phosphate, and hydroxyl ions. So the hydroxyl ions of the hydroxyapatite are exposed on the porous surface of the hydroxyapatite. So these hydroxyl ions exposed to the surface of hydroxyapatite will be able to form hydrogen bonds with the molecules of water that will be found in the sweat. So basically, through a simple chemical reaction, an hydrogen bond created by hydroxyapatite hydroxyls and the water molecules found on the sweat, the DEOHAP will be able to subtract the water from the skin. So basically, it will be a mechanism of water adsorption. Now, since the structure of hydroxyapatite is so much porous, and we can see some images here, so all the pores found on the hydroxyapatite surface will be able to draw several molecules of water. So the saturation level of the surface of hydroxyapatite will be very high. So basically, hydroxyapatite, through its large superficial area and through its pores, will be able to draw a huge quantity of water molecules from the sweat. This will result in a sweat control activity. Particularly interesting is also another mechanism. So here, as you can see, we are playing with chemistry, with inorganic chemistry. So here, basically, what we are going to explain is the mechanism with which the biomimetic hydroxyapatite is able to subtract the malodorous substances from the sweat. So right before, we have observed the mechanisms of action with which hydroxyapatite is able to subtract water from the sweat, so the fluids from the sweat. In this case, instead, we will see the interaction between hydroxyapatite and the malodorous substances found on the sweat. So basically, in this case, the activity of subtracting the malodorous gases will no longer be ascribable to the hydroxyl ions as it happened before. But in this case, the most relevant player working is represented by the zinc. In fact, as anticipated, DEOHAP dry is a mineral, is a biomimetic mineral functionalized with zinc. So the zinc, when included inside the hydroxyapatite network, it will create a sort of status of its orbitals, which will make it as a moderate Lewis acid, able to interact with high affinity with Lewis bases like the malodorous gases that will be found on the sweat. So we will see this mechanism more in detail here. So basically, you can see that the hydroxyapatite molecule on the left side of the screen contains these yellow particles, which are represented by the zinc. Basically, the zinc included in the hydroxyapatite network will have an empty orbital, which will be created indeed by the hydroxyapatite mineral system. So this empty orbital of zinc represents our Lewis acid. So this Lewis acid will show from a chemical point of view an electrophilic nature, which will interact with the nucleophilic nature of the electrons found in malodorous gases. In this case, for instance, we are observing the disulfide, the ammonia and the sulfidric substances that are able to interact with the zinc orbital. So basically, DEOHAP dry works with a dualistic mechanism of action because the hydroxyls found in its mineral nature are able to interact with the water, while the zinc will be able to interact with malodorous substances based on disulfide and ammonia. So basically, it will be hydrogen bonds and a Lewis acid-base reaction. So these are the chemical principles with which DEOHAP dry shows its adsorbing action on sweat fluids and sweat malodorous substances. So here, a very simple image. So we can see this, this structure of the hydroxyapatite, which will be applied on the skin, will form a sort of invisible mineral layer that will be able to subtract both malodorous substances and sweat fluids. So in comparison to the traditional aluminum salts, we have a consistent difference in the mechanism of action because, as a matter of fact, we are not plugging the sweat glands, avoiding the physiological perspiration. The physiological perspiration with DEOHAP will normally take place. The point is that after that, the sweat will be produced, DEOHAP dry will steal it from the skin. So basically, there is no aggressiveness in this mechanism of action. Now, we have observed all the theory. Let's move to the scientific objectification of the activity of DEOHAP. In this case, Kalichem has made very thorough studies to demonstrate both the mechanisms of action that were explained before through in vitro analysis, and also we have made in vivo tests to assess the functional characteristics of DEOHAP dry and how it performs in functional terms when compared, for example, to antiperspirant standards. So here we can see the in vitro adsorption test. Basically, in this case, we have let's say the evaluation of the adsorbing activity of DEOHAP dry on several substances like urea, lactates, and ammonia. Why have we chosen these specific substances? Basically, these substances are the substrates on which the bacteria are acting to promote the formation of malodorous substances. And in order to evaluate the potential of the DEOHAP activity, what we have done is making a comparison against other molecules found on the market with a very well-known adsorbing action. In this case, the parameters of functionality were compared, for instance, with zeolite, with talc, and with a combination of magnesium salts, namely magnesium hydroxide and magnesium carbonate hydroxide. Basically, with this specific test, we are assessing the capability of DEOHAP dry to adsorb the ammonia, and the results speak by themselves. So what we can observe is a better adsorbing performance of the DEOHAP dry in comparison to any other benchmark that was taken under consideration in this study. Only zeolite gets partially close to the activity of DEOHAP dry. So basically what we can observe is that in comparison to all the benchmarks analyzed, DEOHAP dry shows a higher adsorbing action on ammonia. And basically, here we go back to the previous explanation. This activity is related to the nature of Lewis acid that the zinc takes when included in the hydroxyapatite system. A similar test was made also on the evaluation of lactates and urea. So in this case, the model of test is very similar. It is important to also to contextualize this specific test. This test was is a model of test that was introduced by a very popular university in Italy, which has a very high expertise in the study and evaluation of adsorbing materials. It's the University of Milan. So before we have seen the test where we were describing the activity on ammonia, here we are seeing the efficacy of adsorbing substances on lactate and urea. So we still have some very popular benchmarks in the market, in this case, zeolite and magnesium ions, and the results basically don't change. So we can see again that the hydroxyapatite, the functionalized hydroxyapatite, stands performances consistently superior to those of the benchmarks. So in this case, we can see an activity 100% more effective compared to the zeolite, while the comparison doesn't even start, for example, against magnesium salts. And the trend that we can observe on the activity on lactates is definitely the same that we can observe, for example, with urea. So these specific in vitro tests help understanding the mechanism of action of DEOHAP dry, which is basically a raw material able not only to draw water from the sweat fluids, but also and above all subtracting malodorous substrates, malodorous substances that are the substrates of bacteria. So again, we repeat the concept. So in this case, we are observing the activity of a material which is significantly different in comparison to the activity of antiperspirants, because at the end of the day, what we are doing is not avoiding the physiological perspiration, but basically we are allowing the skin to breathe and release its substances through the sweat. And at that point, the DEOHAP will start working through a drying and deodorizing action. So we have seen so far the in vitro tests that help understanding the adsorbing mechanism of hydroxyapatite and how its adsorbing potential stands in comparison to market benchmarks. At this point, let's go deeper and let's analyze the activity observed in vivo. So this is the most important test that is carried out in personal care industry to determine the activity of deodorants and antiperspirants. It is namely a gravimetric test. So this test is a test that, for example, is taken under consideration by the American Food and Drug Administration, the FDA, which defines as antiperspirant substances that are able to reduce the wetness in the armpit area of at least 20% in at least 50% of the target population that is subject to the activity of the substance. So, summarizing and recapping this concept, in order to be defined as antiperspirant according to the FDA, it is necessary to reduce at least 20% of the sweat in at least 50% of the target population. And here we can observe the results of DEOHAP Dry. So it's quite astonishing to observe that DEOHAP Dry exceeds the threshold imposed for the, let's say, the definition of antiperspirant molecule, because in order to be declared as an antiperspirant, we need at least minus 20% of sweat adsorption. You can see that after 24 hours, the amount of sweat reduction corresponds to minus 36%. Whereas after 48 hours, the sweat reduction has a value of 31%. So this test is extremely important because it enables to understand and to stand the claim that a finished product containing DEOHAP Dry works in compliance with the parameters required to be defined as antiperspirant, although it is not an antiperspirant. So this is the key concept to keep in mind, because at the end of the day, an antiperspirant plugs and avoids the sweat, the skin perspiration. So in our case, we are able to keep the same performances of an antiperspirant, but with a non-antiperspirant mechanism. So this is why we defined DEOHAP Dry as a gentle active ingredient, because basically it is not, it does not show a plugging and a, let's say, an obstruction on the sweat glands level. And what's interesting is that this activity is prolonged over time. In fact, we have observed activity not only after 24 hours, but also after 48 hours. In addition to the previous points, so we have observed the in vitro efficacy of the DEOHAP Dry as adsorbing substance for the sweat fluids and for the sweat malodorous substances. And also we have observed the in vivo activity in sweat reduction. Here we can see some additional mechanisms of action of DEOHAP Dry, namely the reduction of sebum, which takes place, for example, with a reduction of minus 18% of the sebum production on the skin, and also a bacteriostatic activity exerted on several species, bacterial species. So here in this case, we can see both physiological and let's say more pathological germs, namely Staphylococcus epidermis, Staphylococcus aureus, Escherichia coli, and Pseudomonas aeruginosa. So basically what's interesting is to highlight that this raw material is not a bactericidal active, but a bacteriostatic substance. So this is important because basically DEOHAP Dry will not affect the local microbiota in the armpit area, which is one of the most, let's say, appreciated claims that today we can make with deodorants, for instance. So basically here we are repeating the concept. So the bacteriostatic action of DEOHAP Dry is the reason for which basically we cannot claim a killing action on the skin bacteria, but I mean a respectful action on the skin microbiota of the armpit. So we have observed all the most relevant points of DEOHAP Dry. So now we will make, again, a recap of the most relevant functional features. So we have seen that in the market, we have a problem today with the deodorants, and namely with substances containing antiperspirants based on aluminum salts, which are known to promote a deep obstruction and potentially an irreversible damage to the sweat glands. DEOHAP Dry, through its unique mechanism of action, which is finalized to reduce sweat fluids and sweat malodorous substances, is basically able to exert an activity, a deodorizing and sweat control activity without affecting the regular perspiration. And as we have seen through gravimetric tests, which are modeled on the, let's say, on the standards of the FDA, DEOHAP Dry works like an antiperspirant, complying to the functional requirements of an antiperspirant, although it is not an antiperspirant molecule. Other points, other key advantages that we have seen is that DEOHAP Dry does not affect the local microbiota of the armpit, because basically it does not have a bactericidal action, but a bacteriostatic activity. And also for another reason, we know that, for instance, aluminum derivatives require extremely acidic pH in their formulations. So usually, for example, aluminum salts require a pH in the formula of approximately 4.5, more or less. When using DEOHAP Dry, we have no pH limitations. So we can either work at acidic formulations, but we can definitely work with neutral pH. So basically, we know that the physiological pH in the armpit area is approximately has a value of approximately 6. So that is definitely a value of pH which falls in the comfort zone of DEOHAP Dry when it comes indeed to put it into cosmetics formulations. Regarding the sustainability of DEOHAP Dry, there are main points, the different points to consider. First of all, the fact that we are using an ingredient which is sustainable for the human health. This is a very important point. And starting from the initial definition of the material contained in DEOHAP Dry, which is the biomimetic hydroxyapatite. It's the concept of biomimetic which meets very well the concept of sustainability, of the health sustainability. And of course, the sustainability topic also regards the production process. DEOHAP Dry is in fact produced according to a unique and exclusive method of production, which complies with the parameters of the EcoScale, which is a semi-quantitative tool to assess the level of sustainability of a cosmetics preparation. And in terms of production score, the DEOHAP Dry production reports a score superior to 90%. So also from a production point of view, this product meets the sustainability requirements imposed today by the cosmetics market. Last but not least, we have also a very important acknowledgement obtained internationally. In fact, DEOHAP Dry was awarded at the 25th IFSCC conference with a poster for its innovative approach in the deodorant field. So here you can see the details of the paper and the poster that was submitted and approved. So here we have a summary of all the potential claims that we can take advantage of by using DEOHAP Dry. You can see that the messages are really heterogeneous. We can claim basically a 24-48 hours protection, sweat control, odor control, gentle activity, the absence of aluminum salts in the composition of the raw material and in the finished product, of course, the respectful action on the skin microbiota, and much more, as you can see. Regarding a formulation standpoint, we have the following applications for which DEOHAP Dry can be used. So DEOHAP Dry is a raw material that has been initially developed in suspension form, which is specific, for example, for emulsions. So mainly for roll-on applications and also for sprays that are not containing alcohol. It can be used definitely in sprayable applications as well, not in aerosol when it comes in suspension form. Lately, we have also introduced on the market a powder version, which is instead specific for anhydrous formulation, namely sticks. So today, summarizing the concept, DEOHAP Dry is a version that is available both for roll-on emulsion application and also for sticks. Here you can see, for instance, an example of a roll-on deodorant. This is an hyperfluid emulsion containing DEOHAP Dry used at a concentration of 20%. So in this case, we are focusing on a raw material which is in suspension form. So basically, DEOHAP Dry is a raw material that in suspension form is concentrated at 30%. So basically, when we are using 20% of raw material, we are having more or less 7% of active matter. So this is the formula that was tested with the gravimetric test that were previously shown. So in order to comply with the functional, let's say, requirement of an antiperspirant, we need to use 7% of active matter of DEOHAP Dry. If we are using the suspension, indeed, we will need 20% of it. So this is the roll-on deodorant formulation. As anticipated, recently we have introduced on the market also a powdery version, which is more specific for water-free formulations. So this is a deo paste. You can see how the product looks on the right side of the slide, where there is a picture of the end product. So this is an anhydrous deodorant paste formulation with sweat control, antimicrobial, oil adsorption, and deodorizing features, where basically we have a final dry touch, dry feel, and a non-sticky afterfeel. So this formulation, as you can see, is a more complex formulation because it contains also other active ingredients that synergize with DEOHAP Dry. So for this reason, you can see that the quantity, the amount of use of DEOHAP Dry is lower than what we have seen before, simply because in this case, DEOHAP Dry is not working alone, but in synergy with the synergistic effect with other active ingredients. So thank you very much for your attention. I hope you enjoyed this presentation.